I was really excited about this because it seemed to say as well that the universe would be expanding and contracting, right? If everything goes towards infinity at the center of all atoms, then the universe is contracting as much as it expands. And I could see how the external part of my existence is the expansive part, and the internal part of my existence is the contractive part. So I started to think in those terms when I was actually 11, and I learned to meditate. A young master of meditation from India taught me to meditate. And I was really excited because I was discovering a whole world within myself that seemed to have infinite potential. So I started to spend more and more time concentrating inward and connecting with that part of my existence. And I start to think that there must be a balance between the expansion of the universe and the contraction of the universe. And the contractive part of that balance equation is the part that generates. And the radiating part is the part that alienates, that destroys. Yet, all of our science, all of the knowledge is based on the radiating part. There's nothing we've really discovered since fire. We explode everything. We put fuel in a rocket, right? Tons and tons of fuel, and we light the bottom, put a few people on top, and pray that they're going to survive the experience. That's our approach. We put fuel in our car, and we explode it in a chamber, and we push a piston up and down. It's all about explosion. And we think the universe is expanding. When much later, I was brought to Georgia Tech to have a conference, kind of a debate with other physicists. These are very well-known physicists, highly regarded, older people that had their students there. And we were talking about things. Some of the students were there. They came in and out. We were, looking at equations. We had all this stuff on the big wall there, on the blackboard. And I showed up with this book. This is the only book I had with me. I had maybe another few, but that was my main book. It's called Gravitation. It's a classical book about relativistic equations. It's written by Messner, Thorne, and Wheeler. Those are legends of physics. Wheeler having worked with Einstein and so on. And it's a brick, you can see. And that's why it's called gravitation. When you pick it up, you know everything you need to know about gravity. And I was going through all the equations, and I could see that the physicists were starting to get upset with me. I was, kind of going through, the way they think of the universal dynamics and the universal expansion and all this. And I finally said, okay, if I understand your model right, and I opened Gravitation on page 719, and I said, if this is correct, then the universe is something like this, which they show you after about 1,000 equations. The model for our universe is a balloon with pennies glued to it. So what you do is you take a balloon, you take a bunch of pennies, and a glue gun. And you glue the pennies to the balloon, and the pennies represent galaxies. And then as the balloon inflates, the galaxies move away from each other, generating the universal expansion we observe with the Hubble. It's called the Hubble constant, or the Hubble expansion, and is observed by various modalities, including telescopes. And so I'm going through this with them, and you got to realize these guys are very accomplished physicists, and they're looking at me going, "Oh my God, this is like kindergarten stuff. If you don't know this stuff, you should go back home and study a little more before you waste our time." And so I was like, well, what I want to know is where is the equation, because I really looked through all your stuff, and where is the equation for this guy? And, the room became quiet. And I was saying, well, this is definitely a component of the dynamics that are going on. And I said, if you keep drawing, if you don't stop at the face, and you keep drawing the rest of the guy, you'll notice that when the balloon expands, the lungs contract. For every action, there's an equal and opposite reaction. First law of physics. That hurt. Everybody had a blank look on their face, and the room became so quiet you could hear a pin drop. And I could see my dear friend and sponsor across the room going, "You're doing damage." Kind of obvious. Completely missed. Obviously, if the universe expands, then something is contracting. And that dynamic of expansion would be a feedback, right? Expand, contract, expand, contract. And it would have a very specific topological structure, meaning it would look in a very specific way. It would have very specific dynamics for things to be able to expand and then contract and so on. So, when you think about it, and I was thinking about it for years, if you radiate, if you look at the universe, you find that everything in the universe radiates. What does it radiate in? In the vacuum. The vacuum of space. Well then, the vacuum cannot be thought of as empty, can it? Because no energy is lost, no energy is gained. So if all the suns, all the stars, all the galaxies, all the black holes, everything we see radiates into the vacuum, then the vacuum must be full. Full of energy. And it was clear to me that then the vacuum must be the contractive side of the event horizon, the contractive side of the structure of reality, the part we don't see. Why? Because it's contracting towards infinity, moving away from us. It appears to us as vacuum. So I was puzzled about that, and I remembered my first class of physics.